My name is Magnus Headly, working with Trimble as the product manager. A year ago, my team and I came together on a shared vision for a revolutionary idea. But first, I'll share with you two vitally important reasons why I decided to participate in this competition. First, I want to acknowledge the effort of young professionals worldwide and my contribution to make the world a better place. Secondly, I am effectively shaping the future of the consulting engineering industry and transforming the way the world works so that I can promote the best practices to be showcasted to others. Within the civil engineering, the problems are clear. 90% of projects are late, 40% over budget. And 60% of the world's CO2 emissions come from the transport sector. Social and sustainable solutions are not holistic optimized. The three essential strengths of my projects are: one, within the domain of the civil engineering, I completely reinvented an algorithm that helps projects throughout the complex process of selecting and generating optimal road and railway corridors. Two, the SINTEF research report substantiates that the algorithm makes it easier to consider all feasible alternatives and plan for sustainability with better environmental and public outcomes. Three, the European transport authorities stated that the algorithms add value for society because the project solution contributes to 50% time reduction and 30% cost and CO2 savings that leads to world planning records. I will continue the journey to achieve advanced integrations among software disciplines and people towards the 7D ecosystem to connect the physical and digital worlds. Thanks a lot.
Good morning. My name is Mary-Claire Daly, and I'm a senior civil engineer with Punch Consulting Engineers in Ireland, and I have particular responsibilities in marketing, strategy, and globalization of the company. The reason why I applied for this competition is I have a vision for the future of consulting engineers as we face into big societal issues in sustainability, the environment, climate change, and now also pandemics. So I believe consulting engineer needs to be seen as a leader on this front. So my project is the National Forensic Mental Health Service Facility. This would be the national centre for treatment of the most vulnerable in our society. These are people that have severe mental health issues. Big items that we came across in the development of this facility were: one, how do we please the client by reducing costs and increasing efficiency? Two, how do we please the local residents who initially were anti the development? And three, how do we improve the sustainability of a 12-hectare site with 10 large sprawling buildings? I am the lead civil engineer on this project. My team estimated in the cut and fill analysis that there would be over 150,000 cubic metres coming from the rising, and traditionally this would have been taken away from the site. However, we provided engineering solutions to ensure the subsoil was reused. We created horticultural plateaus that were topped with topsoil that the patients could use to plant and grow their own vegetables, which works very well in tandem with medical treatment. We also spread subsoil in land within the client's adjacent to the site to use for biodiversity. This greatly pleased the client and the local residents and was a great sustainability initiative as we weren't taking this subsoil away from the site. It also had cost and benefits for the project as well. With the surface water design, instead of attenuating the surface water on site, we let the water flow freely into the adjacent wetlands, and we carried out hydraulic analysis to ensure we wouldn't flood other people's properties. The purpose of this was to rejuvenate and revitalise the wetlands And recently we've had sightings of ducks and ducklings, which just shows the design has been a success. Currently, the site is being used in the coronavirus pandemic fight, where we're actually isolating patients within the facility. So this is where we've handed it over to the end user. This all feeds back into my vision for future consulting engineers, where we're leaders when it comes to sustainability, climate change, the environment, and now also the pandemic. So I'll just share with you an area photo of the site to give you a sense of scale of the development, and I'll sign off there. Okay, thank you very much.
My name is Tomas Johansen, and I work at Citec. I'm located in Turku in Finland, and at Citec I work as the head of our process engineering department. Hopefully you are able to see my screen.
Yes.
Good. I have during the past years participated in a project that is physically to be located in Norway. It's a carbon capture and storage project. The project is currently past its FEED phase and is now awaiting final financing for the final execution of the project, which will, the decision is to be taken within the year of 2021, and after that hopefully this project goes onward into the execution phase. The plan is to capture the CO2 produced at two sites in and around Oslo. One is a cement factory and the second one is a waste to energy plant. The CO2 produced in these plants will be captured using a amine-based technology for capturing CO2. It will be transported to a nearby harbor, from which it will be transported further with a ship out to the Northern Sea and pumped into the seabed into already emptied oil reservoirs. The part of the project I have been involved in is the carbon capture from the waste to energy plant called Klemetsrud, just outside the city of Oslo in Norway. The capture plant or the waste to energy plant incinerates waste from, among other sources, the city of Oslo, and the incineration of this waste produces CO2 emissions as part of the flue gases from the incineration plant. And capturing these in a carbon capture plant has been the content of the project I have been focusing on. The capturing of CO2 requires energy, so a big part of my work has been to find solutions for integrating the waste to energy plant with the carbon capture plant in such a way that the waste to energy plant's district heating production is maintained and the electricity production is, well, suffers as little as possible. So through various thermodynamic models, we have been able to find ways of integrating these two plants while fulfilling the goals of as good as possible maintaining the production of the waste to energy plant. And basically this would then solve two problems, global problems. One, getting rid of CO2, and as a second, getting rid of waste, which is a big problem in the world. So of course this project is now based in Oslo or in Norway, but would have great global potential, and hopefully this can be a first step to get this project or this type of project started and can then be implemented in other parts of Europe and the world as well. Thank you.